All right. In the last class, we started injection molding. We just described briefly what is injection molding, and today we are going to discuss about that in detail. Um, so it's like for the shaping processes for plastics part 3. I think we'll require another lecture on this topic, like shaping processes for plastic. Hopefully, in another lecture, we can finish this chapter. So for the injection molding, it is kind of injecting, like the doctors use syringes to push something inside the vein or something like that. In this process, we also do the pushing with the help of this screw, which reciprocates, and that's why we call this screw as reciprocating screw machine. And the injection, we inject the material, that means the molten material, into a cavity, which we call it the total component, we call it mold. And this is the cavity. Inside the mold, there is a cavity where we inject the material and allow them to solidify for some time, and then we take it out. Then we get another shot of material into the cavity. So if we want to review the previous lecture, the components involved with the injection molding machine, first of all, we need a screw. Okay, it's a reciprocating screw which can move forward and backward, um, with the help of a cylinder for screw ram, with the help of a pneumatic, either pneumatic or hydraulic system, or any clamping system, whatever is suitable for the machine. So we use a screw ram to move the screw backward and forward. And the screw is, as usual, like continuous extrusion method. It should be increasing in diameter when it goes to the forward direction, so that we can compress the material that flows through the cylinder or barrel. Okay. And there will be some vents on these surfaces. There will be some vents to remove the uh, air or any other gaseous product that is within the molten material, to take them out. Due to the compression, they will get out of the mold, and those holes are like 0.01 or 0.02 millimeter size. Molten plastic, because of their high density and viscosity, they cannot flow through those holes, but air or gaseous product can easily get out of this mold, of this barrel. And another component is feed hopper, where we put all the raw materials, which involves like plastic resin, plasticizer, any coloring agent, or any other fire retardant material, something like that. Whatever we need for the final product, we can mix all of them together and then put them into the hopper, and that the screw actually transfers them in the forward direction with its rotational movement. That means this screw does not only move in a reciprocating way, but also it rotates to move the material forward. And there are some heaters. Sometimes there are four heaters attached in here, in the screw outside the barrel. The first one is called preheating element. This heater actually does the preheating of the material, and then it propagates. When material propagates to the second one, it gets heated again and gets molten, and then again, to maintain the temperature, there are some more heaters are placed in along the way of this material, the travel direction of the material. And at the end of the screw, there is a valve. We call it non-return valve. The non-return valve, the function is the screw, the material coming from the screw can go in the forward direction, but they cannot come in the backward direction. However, the image actually showing that the non-return valve, actually there is clearance on the top and bottom, but in real case, there should not be any clearance, so the material does not go backward. Okay. And after that, we have the mold. The mold is this whole thing is actually called the mold. From here to here, this whole thing is called mold. The mold contains two plates. One is stationary platen, and another one is movable platen. And stationary platen, that part will be fixed in here, and when this stationary platen and movable platen comes together, then they produce a cavity inside the mold, and which cavity is the resemble of the final product. It means the dimension and shape of that cavity should be same as the product that we are expecting from the injection molding process. And the movable platen, it can move forward and backward. That means it can move in the both direction, either from this side or that side. It can move in the both direction, and that movement is facilitated by a clamping cylinder. Either a clamping cylinder or sometimes toggle clamps are also used for movement of the movable platen. And there are some other components too, which are not shown in here for the purpose of simplification or simplification. And this, from this mold to the left side, all the components are called injection unit. On the right side, these are called clamping unit. Okay. And in this case, if the clamping is done by using the hydraulic or pneumatic cylinders, then it needs a hydraulic system to operate that one. And the tie rods actually represents as a guide for the movement of the movable platen. And there is nozzle. Nozzle is a narrow hole through which the material gets into the mold. So these are the things involved in the reciprocating screw machine for injection molding. Okay, do you have any question in here? All right, we'll go to the next one. It is like how injection molding is done. So first of all, what happens is that the material is molten, and the movable platen has come towards the stationary platen, and they're fixed in here so that material does not come out of the mold, come out of the cavity. And when the cavity is ready, or movable platen is fixed in position, and then the screw, the hydraulic system actually push the screw towards the uh, nozzle. And due to that force of the valve in here, the material and that happens actually very rapidly, very quick movement, and the material actually get injected into the mold chamber. And that's what you can see in here, like material, the polymer melt is into the cavity. Once the polymer melt is into the cavity, and there is the cooling system in the movable or fixed platen. In the both platen, there is cooling system. That means water circulation channels inside the mold, and it takes a few fraction of a second to do the cooling process. And then after that, once the solidification is done, when the part is solidified, then screw moves backward, and at the same time it rotates. Okay. It rotates and moves backward, so that the another bunch of short of material can get into the into this location. Okay. Fresh polymer melt for the next shot is ready in this place. And once the solidification is done, then movable platen moves to the right direction, and then the cavity is opened, and the molding part that actually sticks to the movable platen. And how this is done? This is done by using a draft, as we discussed in the manufacturing process lectures in your undergrad. The draft allowance, that means due to the inclination of the surface, this part will actually stay with the movable platen. Okay. And when this part is staying in the movable platen, there is some ejection method will be available in the mold. I'll go to the mold, the construction of the mold in the next slide. So In here, I'll just discuss about like how the process works. Then when movable platen goes to the right, then the part stays with the movable platen, and with the attachment in here, the part is gets out of the mold, and then again the process starts with the movable platen sticking with the fixed platen. Okay, do you have any question?
Is there any case where the movable part can be if surface can be problem while we are just removing the mold, as there's cause of cohesiveness of materials between the product material and the moving part
No,
from the injection molding?
there's no possibility in a sense that the mold cavity has to be lubricated before the movable platen and fixed platen sticks together. There's a mold release agent. The name of that is the mold release agent. Uh, is sprayed on the cavity so that the plastic product does not stick to the product.
So there will be system which will spray the
Yes,
mold removing agent at every cycle, right? A kind of.
yes, of course.
Okay, thank you, sir.
All right, the construction of the mold. There are two types of mold actually. Not two types. There are many types, but I'm going to discuss only two types in here. Okay, the first one is two-plate mold. There is only two plate to produce the cavity and to conduct the injection molding process. Okay, the mold actually, the closed one contains a cavity which is like, what's this color? Is it gray or brown? Brown color, right? The brown color actually representing the cavity, and this one in here, this one actually the sprue line, what we say the sprue, the mold nozzle is in here. The nozzle actually puts the molten material into the cavity, and then this is the cavity in here, and the cavity and the water channels that I was talking about in the previous slide. The water channel actually works as a cooling water is supplied through these channels on the both platen. Okay, the fixed or movable, whichever it is, has the water channel to supply the cooling water to cool the part as soon as possible. And there is a support plate that actually supports the movable platen in here, and these are the important thing, the ejector pins. These ejector pins, when the as I said in the previous slide, that the part will stick to the movable platen because of the draft allowance, and when the part is stick to the movable platen, then you need to have some releasing mechanism so that the part can be released very easily. Okay, and that's what is done by the ejector pins. Okay, and this plate actually holds that ejector pins in another plate, actually supporting works as a supporting plate for the ejector pins. And when the material the final product sticks to the movable platen, and these ejector pins are pushed, and then material gets out, and the location of the ejector pin should be in such a way that it does not break the material. For example, if I look at this image, if you look at this image, the ejector pin is located in a place where the material can sustain a lot of load. Instead of this location, if we put the ejector pin in here, there is a possibility that material will break in this place if the material is very thick. Okay, or ejector pin will penetrate through the material. So then there will be problem. So for positioning the ejector pins, you need a very careful observation of the material where the ejector pins should be placed. Okay. Okay. Do you have any question? I'll show you a video of this molds, so things will be more clear in there. And the next one is three-plate mold. Three-plate mold actually consists of three plates. The two-plate is this one, and this one is actually the same as the two-plate mold, and the another plate, actually this one is the fixed plate in here. The fixed plate is fixed, and that actually works as a just only to hold the screw line or the runner. In case of casting, as we know, the material inserts into the cavity through a channel, and that channel is called runner, and that is called runner. And material comes into through the screw, and then using the runner they get uh, into the actual cavities. Okay, so in this case there is three plate is used. Three plates, the benefit of using three plate is that when you make a mold with several parts in several places, then using directly two plate mold is very difficult for the material, and it creates a lot of defects. We'll discuss some defects also. So in that case, what happens is that the material, some material we need to provide the material through these plates using runner, and then into the final product, final cavity. And then what happens is that there is a disadvantage of using three plate is that the sprue and runner, it actually creates another part which is completely useless. This is a waste. Okay, and actual part is formed in the other section of the mold. Okay, and all other things are kind of same. The cooling channel has to be provided in all three cases. Okay. Okay, do you have any question in here?
What is the function of screw bushing?
What? Sprue?
Bushing.
The sprue bushing. That means this is in the fixed plate there is a bush actually. Instead of working on the since this place is subjected to high temperature, so the material that is made, the fixed plate is made of a material which is less less strong or less temperature sustainability than the sprue bushing. That bush is actually a separate part that is placed into the fixed mold, and with a more stronger and more with made with a material which is more temperature resistant. Okay, and it can be replaced when instead of replacing the whole mold, whole fixed platen, if something wrong is in here, or material gets eroded after a long time use, then you can easily change the sprue bushing instead of replacing the whole plate. Okay, that is the benefit of using sprue bushing.
Yes, sir.
Okay, any other question? All right. So there is two video like for showing a two plate mold and a three plate mold. This one is a two plate mold. Okay, in this image video, actually, this is the bushing that we are talking about. The nozzle actually gets stick to this this small hole, and then this that is the bushing. And through the bushing, material is pushed into the cavity, and then the movable plate in here. That movable plate actually moves moves on the other side, and then with the help of screw pins in there. Video is always problem. Same thing happened on the other day, right? With the videos. I might have to close the program and open it.
So you can use the player, just use the player and share the player with.
Yeah, I think so.
So it will be better.
A good idea. All right. Let me go to the folder. Okay, can you see the player?
Sir, clear, sir.
Okay. So what happens is that at the beginning, the material gets into the cavity, which is located, this is the fixed plate in here, and this one is the movable platen. And these are the channels through which the water is circulated to cool the material. Okay. There are some channels. And when the material is cooled and then the movable platen moves backward, okay, after a certain, when the material, the full material comes out of the fixed platen, then the mechanism of the ejector pins comes into play. Okay, when the movement is complete, then ejector plate moves with the ejector pins, and that pins push the material out of the mold. Okay, and these two pins on the top is actually guide for the movement of the ejector plate pins. Okay, can you see this one?
Yes, sir, clear, sir.
Okay.
Yes,
This
sir.
is this is a 3-plate mold. It has a different functionality than the two-plate mold. Kind of similar actually for the two-plate mold. This is the this is the waste product that got out, and this is the actual product in here. So the material actually comes through in this way into the first space between the two fixed plate and the middle plate, and there is the sprue lines. Actually there is two sprue. One sprue is coming from the extrusion screw, and then that distributes along all the materials, or it can be a single part of a single large part, or it can be a very discrete parts. And for discrete parts, you need a sprue injection sprue line for all the parts. And in this case, it's a single part, and you need to have multiple injection locations because of because it is a large part, and there is within a very small time you need to finish the material injection, otherwise there will be defects in the product. Okay, to avoid that, we need to have the multiple sprues, and that's what we are doing with the using of 3-plate mold. Okay, the first that waste material is removed from the system, and then the other part of the mold is opened, and then the ejector pins come into play, and then product is getting out of the mold. All right, there are some other type of injection molding also available. The first one is screw pre-plasticizer machine, or 2-stage machine. It performs the same task but in a different way. Like plunger is different compared to the other one. The other one, the screw itself used as a plunger to push the material into the cavity. But in this case, the screw's function is screw only rotates. There is no reciprocating action of the screw. Screw only rotates and transfers the material through the barrel. And when the material comes out this way and fills up this space, then another plunger that is used in here, another plunger. That plunger actually, when the material is full in the molten plastic is full in this location, and then there is a valve in here, like shut off valve. That valve actually works as a seal. Otherwise, when the plunger is pushed in here, the material can go this way. So to remove, to stop that, a shut off valve is used. Also similar to the non-return valve we used in the other one. But this valve gets off when the material is fixed in here, and then the plunger pushes the material into the cavity. Okay. This is a two-stage machine. The first stage, the material is only molten material is produced, and in the second stage, the injection is done with the help of another plunger. And another type is plunger type injection molding machine. In this case, it's a fixed type of machine. Only a ram is used for pushing the material through the nozzle into the mold cavity. In this case, it's an intermittent process. Okay. This one is also intermittent process, but in this case, you have to when the plunger when the material is in here, first the material comes into the location, and then you use the plunger to push it in here, and then when the material gets heated and plastic gets melted, and then you push the material into the cavity, and after that, when the plunger is moved backward, then another stock of material comes in here, and you push it up to this point, and then wait for some time to get it melted, and then when the melting is complete, then you push again. Okay, and this is a torpedo to when you're doing the pushing to maintain the flow of the material. There is a screen is used, or it's kind of a screen actually to make the material unidirectional. Okay. Okay. Do you have any question in here?
Sir, I have little confusion regarding the cavity. When we are just giving the liquid molten material to the mold cavity, so there is already a air inside the cavity. So does it affect on the
No.
molten?
In the mold, if you have a mold, okay, mold is something like that. Okay, this is the cavity, and there's a parting line. This is called parting line, where this is a movable platen, and this is the fixed platen. And when the movable platen is fixed with the fixed platen, then there will be no air gap, right? But similar to the screw where I discussed, there are some vents of 0.01 millimeter diameter. Similar type of vent is also available in the mold to remove the air. Okay.
Sir, yes, sir.
Okay. It's kind of the sand casting. Do you remember the sand casting?
Yes, sir. Yes, sir.
Venting with the wire. It's kind of same. Okay.
Sir. Thank you, sir.
Okay. Any other?
Sir, I have an observation.
Okay, sure.
Sir, I think in a screw system, the mixing will be better.
Yes,
Isn't it, sir? Because of screw. But in plunger type injection molding, there is no screw, so mixing
will not be. You're not
right,
controlling the mixing. Yeah, definitely.
Mm-hmm.
Yeah, it depends on
That means screw type better for,
yes, screw type,
for
based on
mixing.
application.
And
it depends on the application. Okay.
Exactly.
Because when
application. I don't need mixing in this application probably.
if you don't need mixing with any other material, then you can use this system.
yes, sir. Mm-hmm. Right, sir.
In other cases where you need the mixing is mandatory. In that case, you need to go to the screw system. Okay.
Mm-hmm. Right, sir. Thank you.
And the clamping unit, there I have already told you, like there can be the toggle clamp can be used for clamping the movable platen, and also we can use hydraulic system or pneumatic system for the clamping or declamping. Also, the similar tools can be used for the reciprocating motion of the screw. You can also control the reciprocating motion of the screw with the help of toggle clamp or with the help of hydraulic clamps. This is very important for injection molding. Shrinkage. Whenever a material is subjected to high temperature, it expands. Okay, so when the material expands, with the application of heat, when you are taking off the heat, that means you are removing the heat, you're cooling it, then the material will get shrinked. Okay. The shrinkage is basically due to the distance between the molecules. When the temperature is high, the molecules have high kinetic energy, and the distance between the molecules will be higher, and that will increase the volume of the material. And when the material is cooled, the kinetic energy of the molecule will decrease, and then it will shrink. The size of the material will decrease. For example, you want to make a rectangular part with dimension 10 millimeter and 5 millimeter, and so what should be the cavity size for them? Okay.
Yeah.
The cavity size can be, the final part dimension is like this, 10 millimeter and 5 millimeter. Then cavity size should be higher or should be lower? Smaller or larger than this dimension?
Higher. Cavity size will be higher.
It should have been larger to allow the shrinkage.
To allow the shrinkage. Okay.
Yes, sir. Mm.
If you make the cavity exactly same as the dimension of the part, then after you will get the final part with smaller than that dimension.
Smaller size, right, sir?
This is called shrinkage allowance. Okay. And that shrinkage allowance for different material, that shrinkage is different, because different material consist of different chemical, different chemicals. Okay, so that is why there are some guidelines, and there is a formula. It's a second order formula for determining the size of the cavity when you have the product dimension. Okay, for example, if you have the length 10 millimeter, length equals to 10 millimeter, then dp will be 10 millimeter. Okay, dp will be 10 millimeter, and dc will be the cavity size, and s is the constant, shrinkage constant. Okay, for abs 0.006, it's very small. Polycarbonate is also very small.
Sir, sir, DC টা বুঝতে পারিনি, sir.
DC is the size of the cavity. For example, if you have the final part of 10 millimeter, then dp is that, and dc will be equals to this equation. This is the cavity size will be increased. Okay, based on the factor S. And the highest shrinkage can be from polyethylene. This is for polyethylene, like 0.025, the value of S 0.025. So this has to be in mind whenever you are designing a product, or you are going to make the mold or designing the mold. Then you need to remember this, and you have to, if you want the precision, or if you want the final product to be exactly same dimension as you want, then you have to apply this formula to get the final size of the final product size will be same whatever as you want. Okay. So the next is the defects in injection molding. What sort of defects can encounter when you produce product using injection molding method? The first one is shorts. Okay. The name actually telling you what kind of defect it is, like product shortage in the material, in the cavity. The amount of material needed for the product to be made is less than the amount provided into the cavity. Then you will get like this. There will be shortage of material, and you'll produce the product, but there will be defects like this. There will be no material in that place. Okay. And another important thing is that first one is the shortage of material. Second one is that solidified before completely filling the cavity. Okay, you have a very efficient cooling system, but you did not design the proper injection method. That means injection speed is very low compared to the solidification rate. When the solidification rate is high, the material will get solidified before reaching the far end of the material of the cavity. Okay. Before reaching the far end of the cavity, material is solidified, and in that place there will be shortage of the material and it will be solidified like this. That's a important defect. How can we remove that defect? One, temperature or pressure. You can increase the pressure so that material can get into the cavity very fast, or we can increase the temperature of the material so that material gets high fluidity and become more less viscous, and they can you can get the increased amount of flow rate, increased flow rate into the cavity, and we can avoid these defects. Okay. The last one I have told at
If sir, we slow down the cooling process, then it will be solved.
then your production rate will decrease. Okay.
Sir.
Right, sir.
It will affect the production rate. No? And the cooling actually takes very small amount of time, like a fraction of a second. Okay. And second one is the flushing. It occurs when polymer melt is squeezed into the parting surface between the mold. I think you have seen a lot of plastic products with this kind of defect. Did you? For example, if you are going to buy toys for a baby, and you'll see there are, if the price is low, the product you will get with this kind of defects, because what actually they do is that they don't design the mold properly. Okay. And that is why sometimes they use the second-hand mold. Okay. The mold that is rejected from a good company, and they are selling it to the uh, to the uh, to the small business people, and they are producing the product using that mold. And the mold actually does the moving fixed die, and the moving die does not have proper clamping method, and that is why the material comes out. And another reason for this is that uh, the first reason I have told you, like the defective mold is the first reason, and another is the vents and clearances of the mold that are too large. That means when if there is vent, and the vent size is very large, like for example the vent size that I have said, like 0.01 millimeter. If it's like 0.03 millimeter and you are injecting polypropylene, then polypropylene can get really molten and viscosity is very low. Then in that case the material will come out through the vent. Okay. And that will also cause this kind of flushing. Okay. And another one is injection pressure is too high. Even if you have perfectly matched fixed platen or movable platen, the matching is perfect, the material cannot come out this way, or material cannot come out this way. Okay. But if the pressure is too high compared to the clamping pressure, if the clamping force in here F1 is less than the pressure applied through the screw pins, okay, pressure applied from the screw, then there is a possibility that this mold will get separated from here and some material will get out this way, and that will cause this kind of flushing. And melt temperature is too high. If the melt temperature is too high, then the material viscosity will be very less and it can flow through the small spaces. Okay, and that causes also similar effect like flushing. Okay. Okay, do you have any question in here? All right, next is sink marks and voids. Okay, the sink marks actually occurs outer surface of the mold after solidification, and it is because of the shrinkage or contraction of the internal material. The skin is depressed below its intended profile. Sometimes you will see the dents in the material. It's because of the shrinkage in that place. Okay. And also sometimes bubble up you'll also notice depression in some places. Okay, something like this. It's because of this that shrinkage. Okay, uh, surface material retains its form. Okay, at the first, surface material retains its form, but the shrinkage manifests itself as an internal void. Yes, something like this. The material surface is okay. Okay, material surface is smooth. You'll see something like this. Okay, I think if you have seen the low quality plastic products, in some low quality plastic products, you'll see defects like this. There is bubble inside the material, but when you want to touch that, you'll get a smooth surface, but the void is actually inside the material. Okay, and also if you cut the material cross section, then you'll see some voids in there. It also happens due to the shrinkage of the material, uh, and air entrapment is also another reason for such kind of material. If it does not, injection system does not have enough air removal vents, then air will be inside the material and they will get trapped and create the vents like this. Okay, this is also one kind of defect, and this defect can be addressed increasing the packing pressure. Okay, when you produce the product, then you increase the pressure and then you'll get uh, you can avoid these defects. And a better solution to design the part to have uniform section thicknesses and thinner sections. And these things actually happens, the accumulation of the voids or shrink marks in both cases. If a product has different thicknesses and at different places, then there is a possibility of this, because the small thickness, in the case of the small thickness, they get solidified very soon, but the larger thickness, it takes time for solidification. And outer surface gets solidified, but inner surface gets solidified later. The shrinkage on the outer surface is fixed, but is adjusted, but in the inner surface, the shrinkage can, due to the shrinkage, a void is created in there. Okay, and that is also the reason for shrink marks. So it is preferable to design the product with the uniform thickness. Okay, for the plastic products to avoid this kind of defects. Okay. Okay. Do you have any question? Okay. Another one is weld line. When there is a core placed inside the cavity. Okay, for example, you want to produce a product like this and there is a core place, the white region is the core, the material cannot go in that place, and material is flowing from this way, from this side, and it goes this way and this way around. Okay, something like this, it propagates through that, and the material that meets in along a line. Okay, and that if the material is the mold is cooled very quickly, then this material actually cannot fuse together. Okay, and it creates a line in there. Okay, something like this. Okay, something like this, it creates a line in there, and the boundary thus formed is called weld line and will have definitely lower mechanical properties. Okay, and it occurs due to the you can remove avoid this kind of defects using the higher melt temperature, higher injection pressure, alternative gating locations. That means you put a gate in here, you put another gate in here. Okay, and you put another gate in here, then material will come from 3 direction, and then they will fuse together properly, and then you will get uniform material property. And if you use only one screw line in here, then it's a long distance to cover for material, and the material gets solidified before fusing properly. Okay, and also you need to provide better venting to remove the air from the cavity very quickly, so that material can flow faster throughout the mold. Okay. Okay. Do you have any question in here? All right, next is thermoplastic foam injection molding. How the foams are made. Okay, that means the foam. What do we call foam? If there is void inside the material, we call them foam. And the void fraction is very high, we call them foam. There are two methods actually. In the case of producing thermoplastic foams, actually there is some another additive has to be added, which is called blowing agent. That agent actually produces gas which is trapped inside the material to make the material lighter, and there will be some intentional voids in the material. Okay, and the first method is the low pressure foam injection molding. In the case of low pressure foam injection molding, there is actually no very small amount of pressure in the molding. The material is injected in the mold, and then the blowing agent actually comes into effect, and they spread the material throughout the cavity. Okay, and then the foam is taken out. Okay, the blowing agent actually takes some time to get into effect and produce gas, and when the gas is produced and it gets expanded, the material gets expanded and distributed all over the mold. Okay, and the second method is that the material is completely injected into the mold. Okay, and then the blowing agent, they start functioning. Okay, and then when the mold starts opening, the foam gets expanded. It is the proper example of this kind of foam is the sofa foams. Okay, the sofa foams that we use at home. If you want to squeeze them, you can squeeze them to a flat plate, and then you release it, it gets expanded. Actually, what happens is that in this case, the blowing agent, the gas that is formed due to the blowing reaction of the blowing agent is compressed in here. That's why you don't see the voids in there. But once the material is cured, and then when you remove the mold, then it is expanded. Okay, like this, and then you get the final product. Okay, do you have any question? All right. The final one is injection molding of thermoset material. Thermoset material, can anyone define the thermoset material?
That is a
Chemically changed one,
permanent
sir.
deformation.
No, not the permanent deformation, but
Not recyclable.
non-reversible reaction. Okay.
Yes, sir.
When the material is heated and produced a product, you cannot melt it again. Yeah, there's a permanent chemical bonding.
Yes, sir.
Polymer chain is produced. Okay, so it is same as the previous thermoplastic molding. Only difference is that when the material is mixed together and injected into the mold, and then you need to maintain some temperature into the mold for the curing. For example, if you need a temperature like 250 degrees Celsius, okay, and then you put it in here and keep it at some temperature, that means the curing temperature of that material in here, and then you keep it for some time at that temperature to allow it to cure. Once it is cured, then you take it out, and then another shot of material comes into the mold. There are many different ways. For example, if I talk about the epoxy, okay, the epoxy at room temperature, you mix part A, part B, that means the epoxy and hardener, you mix them together, and then you flow it through the injection molding and put it into the cavity, and then you apply a temperature of 125 degrees Celsius for like 2 minutes or 10 minutes. Then this material gets cured, and then you take it out. Another bunch of material comes in here, we are subjected to that temperature, it becomes cured, and you take it out. Okay, something like that. It's the injection molding of the thermosets. Another one is the reaction injection molding. If you have to make a reaction for the setting of the material for producing the polymer, then there is only two ingredients shown in here. It can be more than two. Okay, The required proportion of material is supplied through the ram injection piston into a mixing head where the materials get mixed together, and then after mixing they we push using that injection piston, we push them into the cavity and allow them for the solidification, and then we start another shot. Okay, and the chemical reaction actually takes place at the mixing head. This can also apply with the epoxy that I have told you. For some epoxy parts, you can produce them by mixing resin and hardener. Hardener, you put it into the mold, and then you remove that mold, put another mold, and you take the material and keep it in another place for some for 24 hours. It requires 24 hours for curing. Then you keep that mold in another place for 24 hours, and then after 24 hours you take that material out. Okay, so this is so far for injection molding method, and in the next class we'll discuss the compression molding. Not only the compression molding, there will be some other topics too, the blow molding or any other type of plastic processing techniques. We will use that. And do you have any other question today's lecture?
Sir, can I add something, sir, if possible?
Yep, sure.
Sir, at our campus, at department, we have injection molding machine, and there I have saw that see that there is a planetary gear system for projectile the force equally when the plunging is happening, when we are just pushing the molten plastic at the cavity, mold cavity. So you just said that we have to distribute the molten plastic within a short time, equally distributed. So at that machine, they just do this with the planetary gear system from the four corner of the mold cavity.
Gear system.
Yes, sir.
Where did they put that?
They just use a sun gear from the main power supply, and sun and gear. So gear or planets are used for the four planets gears are used with the sun gears. So sun gears used from the is having their power from the main power source, and the planet gears are just feeding the plunging system for the molten plastic.
Yeah, there are some different ways. Okay, it can be another way for
yes, sir. Yes, sir.
making the materials. Okay, because nowadays when the technology is advancing, there are many other things getting in place. Okay.
Sir, sir.
I have not discussed another thing is like there are twin screw extruder. It has two screws in the barrel. Okay, so to get more effective mixing as well as more effective injection. Okay, so day by day the technology is getting enriched. All right, I'm going to stop